Welcome to Next Gen Theories. Before we dive in, help us reach 10,000 subscribers. Your support keeps us going and fuels more in-depth tech episodes like this one. Today, we're exploring a major shift in how Tesla plans to operate its factories. Specifically, how the Tesla bot, Optimus, could revolutionize the production process for Tesla's new Cybercab at Giga, Texas. Elon Musk recently reaffirmed on X that Tesla's next-gen production lines, especially for the Cybercab, are being designed with full automation in mind. At the heart of this vision is Optimus, Tesla's humanoid robot, which Musk sees as playing a critical role in the future of manufacturing. This statement makes it clear. The link between Optimus and the Cybercab isn't just incidental, it's central to Tesla's long-term strategy. These two can be seen as complementary robotic platforms. Optimus represents a bipedal, human-like robot capable of navigating and interacting with the physical world, while the Cybercab is a wheeled autonomous vehicle optimized for transportation. What's especially noteworthy is that Optimus is expected to become a key part of the large-scale Cybercab production effort at Tesla's Giga, Texas factory. According to Musk, Optimus will be deeply integrated into the assembly process, taking over numerous tasks with high mechanical precision, and in some cases, replacing the work of up to 3 human employees. So how exactly will this happen? And when can we expect Tesla to fully deploy this automation? That's what we're unpacking in today's episode. Before jumping into the specifics, let's zoom out for a moment. We're entering an era of rapid industrial transformation, and AI is acting as the main catalyst, accelerating change faster than many experts predicted. Tesla, traditionally known as an EV manufacturer, is actively reshaping itself into a tech company where AI drives both innovation and operations. From Tesla's full self-driving FSD system to the Dojo supercomputer, built in-house to train AI models, and now with Optimus, Tesla is embedding AI across its entire product ecosystem. One standout innovation is what's known as post-assembly autonomy, where robots or vehicles, once completed on the line, can immediately move themselves to designated locations without any human help. It's similar to how FSD-equipped Teslas can drive themselves out of the factory. Tesla wants to extend this concept to humanoid robots, making Optimus capable of finishing its own assembly and heading straight to work. This is what sets Optimus apart. Unlike traditional AI, which might just guide you on how to fix a leaking pipe, Optimus, powered by AI and mechanical actuators, could identify the issue, plan a solution, and physically fix it. This represents the shift from passive AI, advice giving, to active AI, real-world action. Globally, the race to develop humanoid robots is heating up, with major efforts in both North America and Asia. Still, Tesla's Optimus remains one of the most talked about humanoid robots, not just because of its tech, but also because of the massive attention Tesla commands. People are equally excited and skeptical, watching to see how far a company known for EVs can go in this high-stakes robotics arena. Musk has emphasized that Optimus follows a unique development path, one that differs from conventional humanoid robot projects. Tesla designs and manufactures everything in-house, from mechanical parts to the software and microcontrollers. This gives the company a huge strategic edge, particularly when it comes to keeping costs low and achieving scale. One of Tesla's advantages is its ability to reuse and adapt components from its EV lineup, like drivetrains and battery systems, for use in Optimus. This synergy between Tesla's automotive and robotics divisions could make it one of the first companies to mass-produce affordable humanoid robots. In summary, Tesla isn't just building cars anymore. It's building an ecosystem where AI and robotics play a central role in how products are designed, assembled, and even operated after production. If Optimus performs as Musk envisions, it could fundamentally transform not just Tesla's factories, but manufacturing as a whole. Stay tuned as we break down when and how Optimus might be fully deployed, and what that means for the future of automation. Tesla is taking a major shortcut in the humanoid robotics race by reusing key components it has already perfected in its electric vehicles, such as electric motors, battery modules, and high-power electronics. This approach not only slashes development time, but also lowers production costs and ensures technical consistency across its products. While other companies are starting from zero, developing each robotic system independently, Tesla is leveraging its existing manufacturing strengths. This gives it a significant head start in deploying humanoid robots and pushes the company further ahead in the race. Elon Musk is confident that Optimus, Tesla's humanoid robot, will eventually become the most intelligent robot of its kind in the world. That's thanks to a design philosophy focused on replicating human capabilities as broadly and deeply as possible. Powered by Tesla's own AI system, developed entirely in-house and enhanced with advanced perception and behavioral algorithms, Optimus is built to take over repetitive, physically demanding tasks that most people prefer to avoid. The second-generation Optimus has already reached a significant milestone. It can now perform around 1,000 different tasks in real-world settings. However, the true leap forward is expected with Generation 3, the upcoming version, which could support virtually limitless task capabilities. Just like the human brain has near infinite cognitive potential, Optimus will be limited only by physical hardware. But since it's equipped with actuators stronger than human muscles, it could go far beyond what people are physically capable of, opening up new possibilities in manufacturing, service industries, and even daily life. Though Tesla is globally known for revolutionizing electric vehicles, Musk believes Optimus may become the most strategically important product Tesla has ever created. In fact, he's gone as far as to say that if it's successfully scaled, Optimus could eventually push Tesla's market valuation to $25 trillion. A bold claim, but one that highlights how central robotics is to Tesla's future. According to recent updates, Tesla plans to build at least 5,000 Optimus units this year at its Fremont factory. And by 2026, the company aims to increase production to 50,000 robots annually. Musk mentioned that Tesla technically has enough parts to produce up to 12,000 bots this year, though he admitted that figure may be overly ambitious. So for now, 5,000 units is the realistic target, still a game-changing number for 2025. The plan may sound modest for a company known for mass production, but it's a reasonable and strategic move. Building a humanoid robot is a far more complex challenge than assembling cars. Unlike EVs, which Tesla has spent years perfecting, Optimus requires the development of an entirely new assembly line, much of which is still being done manually. Plus, the company needs to recruit highly skilled workers, manage supply chain complexity, and fine-tune both the software and hardware in real time. This is why Tesla is actively hiring for roles specifically tied to the Optimus project, and why the company has reportedly completed a temporary facility dedicated solely to assembling these robots. Recent images show at least 8 nearly completed Optimus units, with dozens more on assembly trays in the background. This is no longer just one of Musk's bold predictions. It's physically happening. Engineers are currently focusing on finishing the hands and arms, paying special attention to the design of the robot's hands, which are crucial for high-precision tasks like holding an egg or serving a drink. This suggests a strong emphasis on fine motor control, which could allow Optimus to take on jobs requiring delicacy and coordination in the future. Interestingly, while most of Tesla's competitors are racing to build robots that run, jump, or perform acrobatic stunts, Tesla is choosing practicality over flashiness. The goal isn't to entertain or impress with flashy demos, but to build a robot that can safely and efficiently work alongside humans in factories, homes, and businesses. While some robots today are known for their awkward or even silly movements, Tesla is focusing on precision, especially when it comes to Optimus's hands. Research shows that fine motor skills, like grasping and manipulating objects, require tight coordination between the brain and the hands. Think of playing the piano. Every finger must move with perfect timing, rhythm, and pressure. That level of coordination demands extremely complex information processing, and it's this type of interaction that Tesla is working to replicate in Optimus. So, what sets Tesla's long-term vision apart from its competitors? In another major move, Tesla is advancing its Dojo AI training system. The company has made massive investments in AI infrastructure, both by purchasing NVIDIA's top-tier hardware and building its own chips under the Dojo program. The first generation of Dojo chips is already showing promising results. Tesla managed to pack 25 Dojo chips into a tile the size of a dinner plate, drawing about 15 kilowatts of power. While it's still uncertain whether Dojo will outperform NVIDIA-based supercomputers, Tesla's strategy is clear. Build an AI system that delivers competitive performance at a fraction of the cost. If Dojo can offer just 20% more performance at only 10% of NVIDIA's cost, it could completely reshape the economics of AI training. Dojo 2, the next generation chip, is expected to enter mass production in the coming months. Musk claims it will deliver 10 times the performance of Dojo 1, reaching an astonishing 3.6 petaflops. If that's accurate, it could outperform NVIDIA's H100 and even beat the B200 by as much as 40%. Even if the raw power is similar, Tesla's edge might lie in cost efficiency. For example, if Tesla can build Dojo 2 for $10,000 and it matches a $40,000 B200 in performance, the value proposition is undeniable. Since August 2024, there's been growing buzz around Cortex, Tesla's massive new AI supercluster in Austin. It's built to train real-world AI models for full self-driving, FSD, and Optimus, with huge storage capacity dedicated to video data. Compare that to Figure AI, another US-based robotics company. While Figure also uses in-house AI and recently announced a breakthrough in combining high-level reasoning with motor control, it seems to lack a long-term strategy for AI infrastructure. In contrast, Tesla has been building toward Dojo since 2019, officially launching it in 2021, and is now scaling it with Cortex, reportedly featuring around 50,000 NVIDIA H100 GPUs. Tesla's progress on Optimus has also been rapid. The third-generation Optimus is expected in 2026 once the current production line stabilizes. Tesla plans to pilot the robot in select strategic sectors, offering the most advanced version for commercial use. The starting price could be around $50,000, but this version will be capable of handling a wide variety of tasks. Interacting with Optimus could become part of everyday life. It might remind you to take your medication, alert you about appointments, or help older adults navigate new technologies by providing simple guidance on using smartphones or tablets. For kids, Optimus could become an interactive learning assistant, teaching through games and puzzles thanks to its natural communication abilities. Musk has clarified that Optimus production is still in a developmental phase. Tesla won't jump into full-scale manufacturing just yet. Instead, the plan is to produce a few thousand units, mostly toward the end of the year, with a focus on refining the process. Tesla isn't the only company exploring robots as a service, but its vertically integrated ecosystem, spanning battery production, AI, and advanced manufacturing, gives it a strong head start. Tesla is likely to begin testing Optimus through rental programs in key cities like Fremont and Austin, where they can gather real-world data and feedback before scaling up. To accelerate adoption, Tesla might partner with home service franchises, embedding Optimus into a broader support system for households and small businesses. What do you think about Tesla's robotics vision? Share your thoughts in the comments below. If you enjoyed this deep dive, give us a thumbs up and don't forget to subscribe to Next Gen Theories and hit the bell icon to stay updated on all our latest tech content. Thanks for watching, stay safe, and have fun.